Hello YouTube, this is Sam from Tigers Schooling, and this is the second part of the introduction to bioenergetics. In this section we're going to talk about the Gibbs free energy, exergonic reaction and endergonic reaction. So we're not going to go that much detail regarding the Gibbs free energy. I'm just going to explain it superficially. So if you want to understand about the Gibbs free energy in detail, please watch our other videos. And we'll be talking a little bit about the exergonic reaction, endergonic reaction, and its involvement, its its dependence on the Gibbs free energy, how these things are related. So the kind of Gibbs free energy, you can define Gibbs free energy in a sense, which is represented by the formula delta G is equal to delta H minus T delta S. So you can define the Gibbs free energy in a sense that it's actually a thermodynamic quantity. It's just a quantity equal to the enthalpy. This one is the enthalpy of a system minus the product. Product means multiply. The product of the entropy and the absolute temperature. Remember, this is the absolute temperature. Remember this one. So very simple to define it. A thermodynamic quantity equal to the enthalpy, a system of process minus the product of entropy and the absolute temperature. So this is how you're gonna define the Gibbs free energy. So the Gibbs free energy, in this case, this G is showing the Gibbs energy. This is the enthalpy, T is the absolute temperature, and this is the, you can say, the entropy. So what happens, for example, the Gibbs free energy is equal to delta H minus T delta S. So consider if we're going to increase the value of this delta H, keeping the value of this one constant, not increasing it. All right. So if we're going to increase the delta H, which is the enthalpy, we're going to increase the delta G. But if you're going to decrease the delta H, we're going to decrease the delta G. In similar case, if you're going to increase the temperature and the entropy, temperature or entropy, entropy means disorderness, or causing disorderness. For example, we got two chambers, we got orderness here, but if you remove the this partition, we're gonna get distorted, the particles are moving apart. So this kind of shows this. If the molecules are more distorted, the distortion is increased, entropy is increased, the value is increased. And in this case, if this value is increased, which is actually is in minus, so the delta G is also going to in minus. So if the Gibbs free energy is in minus, if you can say so, if Gibbs free energy is actually in minus, it's an exergonic reaction. So if in negative, it's an exergonic reaction because it's going to release energy. But if it's going in positive sense, it's actually the endergonic reaction. Now let's talk about the exergonic and endergonic reactions in just a quick review. So the exergonic reaction, or you can say exergonic process, is actually a process in which free energy, which we talked about, the Gibbs energy, changes are negative. This is one is a negative. So and one thing more to add up, exergonic reactions are spontaneous. They are spontaneous, happen very rapidly. The exergonic reactions are spontaneous. Also, they're also called as the catabolism. Catabolism, breaking something, distorting something, destroying something is very easy. Making something is very hard. It's very hard to make up things, but to destroy them, you need seconds, minutes. You just destroy them. So exergonic reaction means destroying. It's a negative value in delta G concept. It's very spontaneous, very fast. And the catabolism, we have just talked about it. We will talk about in the section of metabolism. Catabolism is actually means the breaking down. We'll be talking about in detail in other videos regarding catabolism. Just understand it here by the destruction of the molecules. Another one thing we have to add up is the reactant concentration are higher than the equilibrium. So in the exergonic reaction, the reactant concentration are higher than the you can say the equilibrium, the value equilibrium when product and reactant are equal, so the reactant value will be more than the reaction concentration will be more than the equilibrium when they're both more than the product, or you can say more than the equilibrium, right? So if we're going to, now we're talking about the endergonic reaction. In case of endergonic reactions, the delta G is positive, so it's again we go again like this. It's not spontaneous. It's not, it's unfavorable. This one is favorable. So in this case, reaction happen in opposite direction. In case of exergonic reaction, we go A to B, but in case of endergonic reaction, we go B to A. That's a pretty odd concept, but it's this way. So the product concentration, in this case, in Gibbs, in the endergonic reaction, product concentration are higher than the equilibrium concentration. So you will write P is greater than the equilibrium concentration. All right, this is the endergonic reaction, this is the exergonic reaction. That's it regarding these basic concepts. I hope I have cleared the introduction regarding the bioenergetics. It's not a detail. We'll be making detailed video regarding the bioenergetics in our coming lectures. Thank you, and keep visiting Exergonic Schooling.